Okay, let's read this together. A chocolate factory will make boxes of chocolates. The fixed costs to begin the operation are $72,798. Also, each box of chocolates will cost an additional $8.50 to make. Each box of chocolates will be $8.50. Then they're going to be sold for $25 a piece. And the question's asking how many boxes of chocolates need to be made and sold so that costs and sales are equal. So we have a cost side and a sales side, and we're going to need to assign a variable here because it depends upon how many boxes of chocolates are going to be created. So let's start off by we're going to let x represent something. X is a variable that and it'll represent a number for us. So we'll let x equal the number of boxes of chocolates. And we will assume that we sell all the ones that we make. So we're really looking for how many do we need to make so that if we did sell them all, that we would break even essentially in this business application. So I purposely chose the colors to underline as separate colors, or blue and green, so that way we can look at them separately inside of the equation. What are the costs? Costs are in blue. Well, according to this problem, there's $72,798 in startup costs. So that would be like buying the machine for the chocolate. You only have to buy the machine once, right? Things like that are called fixed costs. But in addition to that, there's also some of what we sometimes call variable costs. Each box of chocolates costs $8.50 to create. And that would be the cost of like the actual objects that go into the chocolate or the wrapping, or the more boxes you create, the more these costs are going to have to add up and become more. So of course the total amount of cost would be what we would get when we add these together, but $8.50 was per box of chocolates. So we actually have a variable that goes in here to say that if we only created one box, it would be $8.50. But if we created two boxes, we would need $8.50 times 2, because each cost of the $8.50 has to be multiplied by however many boxes of chocolates you actually end up creating. Now, what would the sales be? Well, the sales are a little bit more straightforward. Every box you sell is $25 a piece, so $25 goes over here. But yet again, we do have to insert a variable, because if we only sell one box, that would be 25, but if we sell two, it would be 2 times 25. So if we sell x, it's going to be x times 25. And put an equal sign between these two expressions because we are looking for where they are equal. And now we're into algebra land. We just have to do our algebraic skills to try to isolate the variable. Okay, so to that end, let's subtract 850x from both sides of this particular equation. And this will leave us with left-hand side 72,798. And on the right-hand side, we have 25 minus 8.5. Let's see, that would be 16.5. And x, because of the variable. One last step towards isolating the variable: divide by 16.5. Divide by 16.5. Remember, whatever we do to one side also has to be done to the other. So now those reduce x, and on the left-hand side we have 72,798 divided by 16.5. And this comes out to be 4,412. So that's the answer to the problem. If we created 4,412 boxes of chocolates and sold them all, then we would not only make up the variable cost of what it costs for us to create the actual boxes of chocolates, but it would also cover the fixed costs that it took to begin the operation.